Hello, everybody. In this lesson, we're learning about the derivative of a function and all the rules that are used to calculate the derivative. And I've already posted some videos about how to do that, how to use the rules and so on. And so I want to talk about application, okay? And it will involve a profit function and then something called marginal profit. I've already made some videos discussing what marginal revenue is, and now we can translate that same concept into profit and marginal profit. So here's the situation that I want you to think about. Suppose we have a watch vendor, and I got this off of our assignment on my math lab. There was something similar to this, but watch vendor, and X will be the number of watches sold, and P of X will be a function that calculates the profit from the sale of X watches. Okay, and that function is P of X is 0.08 X squared minus 4X plus 7X to the 0.5 power minus 4,500. Okay, now, say that is what it is. This is a function that tells us what the profit is from selling a certain number of watches. All right, and how somebody would generate that function is beyond the scope of our class, but it can be done, and at least can be done within a certain level of precision. It might not account for uncertainties and things that nobody could predict and so on, but within, fairly reasonable limits, it will give you a good approximation to profit. So that's how we have to understand this function. It's not a crystal ball. It can't look into the future because nobody and nothing can look into the future. All right, but it's a reliable model that we can base our analysis of. That's how you need to think about that function. So suppose we want to calculate the marginal profit function. As far as that goes, when you hear the word marginal in math and economics, this is a signal that we're going to be calculating the derivative of something, okay? Derivative, sorry. All right, we're going to calculate the derivative, or, if our function is P profit and we're looking for marginal profit, then it's going to be P prime, where the prime is our notation to indicate that it's the derivative. So the marginal profit function is the derivative of the profit function. The marginal cost function is the derivative of the cost function. Marginal revenue is the derivative of the revenue function. You see a pattern, right? Okay, so if I was going to calculate the marginal profit function, that's the derivative of this profit function, I would get this, and I would get that from our rules. Now, I didn't write out the work when I made this slide, but I'd like to show you now, okay? So here's P of X, our profit, and I want to find P prime. Our rules for derivatives are like this. For the term 0.08 X squared, I would leave this 0.08 and bring down the exponent from the x squared, and it would be 2x to the first power, okay? That's our rule, and if you're uncertain about the rules, you'll have to consult the earlier video on the rules, okay? And then the derivative of negative 4x is negative 4, and 7x to the power 0.5, well, that's going to be 7. I bring that power down, and I subtract 1 from it. So that will be 7 times, bring the 0.5 down, 0.5x, then I do 0.5 minus 1. Again, that's the rules, and you need to go back and study the rules if you're not familiar with them. And then the derivative of any constant, 4,500, that's 0. So I get this, and that leads to my final answer. 0.08 times 2, that gives me this coefficient 0.16x minus 4, okay? And then 7 times 0.5 is 3.5 times x to the negative 0.5 power. All right, that's our marginal profit function. Now, what I'd like to do next is talk a little bit about the interpretation of what this function tells you, because the P of X, the profit, tells you the profit. You tell me how many watches are sold, and it will estimate what the profit will be in that situation. Okay, so what does the marginal profit tell you? Economists talk all the time about marginal this, marginal that, marginal cost, marginal revenue, marginal profit, whatever. So what does it tell you? I mean, I know what P of X tells me. What does P prime, the marginal profit? So we'll discuss that down here. Let's use some numbers though. Calculate the marginal profit for a sale of 200 watches, then calculate the marginal profit for a sale of 1,000 watches. Well, that would just to do the calculations and put the number in, okay? You know, here's my marginal profit function. If you want to know what the marginal profit is under a sale of 200 or 1,000, put 200 or 1,000 in. And I do the calculations. I rounded these numbers to the nearest dollar, okay? Normally when we do something on my math lab, if I'm basing this off something I saw in my math lab. I think the question on my math lab said to round to the nearest dollar or something like that. So I really got 28 point something and rounding to the nearest dollar, which is 28. Same over here, 156. Now, these are different. And I wonder about, well, why are they different? And what does the number themselves mean? Okay? Now, all derivatives tell you how two variables change together. Okay? All derivatives are like that. Now, if in general y is equal to a function of x, then the derivative y prime or f prime of x tells you the change in y over the change in x, just in general for any derivative. So for my marginal profit function, being the derivative of my profit as a function of sales, units sold, then this would be the change in profit over the change in sales, okay? So, all right, let's interpret that. 28 is the change in profit over the change in sales. So that's like if, you know, maybe you would like to see a 1 under it. 28 over 1, okay? So if our sales change by 1, or if our sales increase by 1, our profit increases by 28. So that's what it means. That's how we interpret the number. At a sales level of 200, so that's the significance of the 200, an additional unit sold will increase profit by $28. So at a sales level of 200, an additional unit sold will increase profit by $28. All right. And then this one, P prime of 1,000 is 156. If sales change or increase by 1, profit changes or increases by 156 at a sales level of 1,000. So at a sales level of 1,000, an additional unit sold will increase profit by $156. So two things I noticed about this. Here are the interpretation. This is the meaning. And if we are going to learn math to study economics, then we'll have to know what the numbers mean. That's what the numbers mean. And so I noticed that as sales increase, at least over this range, the marginal profit increases. So it's like as sales increase, the way we can increase our profit from increasing sales goes up. All right, that's how you can think about it. So at a sales level of 200, that additional sale increases your profit by 28. But at a sales level of 1,000, that increasing sale increases your profit by more, 156. Okay, why is that? Well, that's the way some things are. It might be the nature of the structure of the company and how the startup cost or the fixed costs are factored into the variable cost. There's lots of different ways. The market might be complicated, but it's more profitable to increase sales from 1,000 than it is from 200. That's what it tells us. All right, think about it like this. P of x tells you what the profit is, and P prime of x tells you how the profit is changing. That's the function versus the derivative. Now, I thought I could illustrate this in another way. Economists normally will use the derivative to calculate marginal profits, costs, and revenues, and so on. But let me show you that these numbers here bear out to truth. Okay, so now what I'm showing you now is not calculus. All right, so that's a disclaimer. But I just want to use something basic, something simple to illustrate what I just told you about the marginal profit. So in here on the spreadsheet, I put in a column for X because I wanted to do some calculations, and then I put this profit function into this column. Okay, and I had to use the syntax of Excel, but this is that function 0.08x squared minus 4x. It's all that in Excel syntax. If you don't know how to use Excel, it's time to learn. Excel is such a common tool that people use. I think everybody should know it. So this tells me, let's do 200 first. Okay, this tells me that at a sales, if I sell 200 units, my profit is negative 2001. I'm losing money. It's like I've got to sell a certain number of these watches to even break even. Okay, so I'm in negative profit territory at this. But look at this. As I compare my profit of at a sales level of 200 versus my profit at a sales level of 201, look at what the difference is. This number right here is this profit level at 201 minus this profit level at 200. And look what it is. It's 28. That's about the number I got. How would you interpret this? If the sales go from 200 to 201, the profit increases by $28. It might be negative, but it went up. It became less negative by $28. Okay? So we haven't even broken even though yet at a sales level of 200. Okay? But I got the number. I showed you that that's true. At a sales level of 200, an additional unit sold will increase profit by about $28. Now you're looking at it right there, just by arithmetic. What was our other number? 1,000, a sales level of 1,000. So let's put in 1,000 and compare it with 1,001. Okay. Now by the time we've sold 1,000 watches, we're past breaking even. Now we're making profit. Okay. Profit's about $71,000 at a sales level of 1,000. But look how the profit changed at a sales level of 1,001 versus 1,000. Profit that went up by, what's this? Here, this number, I subtracted this profit minus that one, about $156. So at a sales level of 1,000, if I increase my sales by 1 unit, that's 1,000 to 1,001, my profit went up by $156, just as the marginal profit derivative predicted. Okay, so now this is just arithmetic. This is just calculating the profits and subtracting to see how it compares from increasing our sales by 1 unit. But I can give some indication to those marginal profit numbers along with the interpretations that I gave you. So I thought that that would be a helpful way to look at our derivative, okay, and our interpretations in a way that just involves subtraction, okay?